Right. Hello, everyone, and welcome to the 96 Boards and Drones presentation. I'm Said Sarup. I work as an application engineer with the 96 Boards team at Lenaro. And today we'll be talking about some of the drone work that's been going on and our partnership with PX4 and fun stuff like that. So let's get started. So this basically is a combination of 96 boards tech and PX4 autopilot tech. We are very similar in ways that 96 boards has specifications for standardized set of hardware, and PX4 does the exact same thing but with drones. They also have their awesome autopilot software stack based on the Nutex RTOS, and that's amazing as well as stuff like Q ground control and other things to manage and fly a drone. But today we're talking about the 96 boards drone, and we are partnering with Gumsticks to manufacture the initial few boards, and they have been very active in the PX4 community, and they were very quick to take us up on the offer. So, purpose of this project, we basically wanted to expand the 96 boards drone ecosystem now that it's under a proper 96 boards auto edition spec, which is still a work in progress, but we've kind of announced it on our website. And we wanted to improve upon our previous attempt with the AeroCore 2. The AeroCore 2 was again by Gumsticks, and it was again a PX4 base board, but it was kind of outdated. I did try and sort of bring it back to life, but if you've read a few of my earlier blogs on the topic on the 96 Boards website, I quickly realized that a lot of things we see in the drone ecosystem right now are more analog than they need to be. And stuff like just using PWM to control the ESCs and things like that. So wanted to get into a platform that's capable of doing UAV CAN and completely digital transmissions and other things. So something like this is still just get this sort of a controller out of people's hand and somehow make all of that digital. Now PX4 does do that already, but we just wanted to explore how we can go further with that. Again, this project was always about bringing the 96 boards ecosystem with the PX4 ecosystem. So it's about exploring how we can combine the RTOS functionalities of the PX4 with the AP, your application processor plus acceleration platform like an MPU or an FPGA from the 96 boards ecosystem, and put that on a single board, a single platform, and what all you can do with that sort of compute platform, basically. Again, some of the use cases that we were thinking of is like real-time 3D mapping, photogrammetry, live train, point cloud, and yeah, I'll talk about these a bit later in the topic as well. But yeah, so we are targeting people who have or already have experience in the drone ecosystem and want to expand their horizon, do much more cooler things with drones. So what is PX4? A quick introduction. It's an open source flight control software for drones and other unmanned vehicles. They provide a flexible set of tools for drone developers, like their autopilot and their Q ground control apps. And they provide a standard to deliver drone hardware and software stack. So that's their FMU or flight management unit standards. And that's what we use as well. And they allow an ecosystem to build and maintain hardware and software in a scalable way. Like they've been here forever in the drone ecosystem. They've like the PX4 autopilot now even works for rovers. If you have airplanes, like non-VTOL aircrafts, even like those balloons. But yeah, they are very versatile in anything aerial. And then, as I said, they're also going into rover or ground-based systems. So meet the PX4 FMU V5X. it's not 100% release now, but they've announced it. The spec is live, and as you can see on the pic, I have an image, and that's actually the drone I built flying. So the CPU is an STM32F7. So again, an Cortex M7. The specs is around 200 to 400 megahertz. 2 megabytes of memory, 512 kilobytes of RAM, and this is like the rough spec they say on the on the standard page, on the PDF, and everyone kind of just builds their hardware, whether it's Audio Pilot or it's Holy Bro, around those set of standards. And FMU is like a standardized SOM that you can put on your drone baseboard. And you have a bunch of sensors you can select from. And if you upstream it to the main PX4 autopilot firmware source, they'll maintain it and they'll provide binaries. So like FMU V5X, the one we are working on, is already upstreamed. That flight was actually done on the master branch, which was kind of amazing. But I had to do some PID training, and the PX4 folks did help me with that. So initial overview, the basic goal, again, let's explore this a bit more, is to take 96 boards, whether it's in a SOM form factor like this is the 96 board SOM spec, or if it's in the regular CE form factor. I have a CE extended right here. And to be able to combine both of these with a FMU, so you either get 96 boards mezzanine if you're talking about the CE spec, or 96 boards SOM baseboard if you're talking about the SOM spec, and just design and manufacture those platform for initial testing to explore how we can communicate between the two hardware. What sort of application do we need to run on each of this? Who's controlling the main navigation? Who's controlling the stability and flight profile and stuff like that? And just explore as many ways to connect these two hardware and see how all of that comes together. So expose as many IO as possible, which was not quite something that we did with the CE mezzanine, as you'll see in the next few slides. But with the SOM spec, we exposed really a whole lot of things, like on PCB, Ethernet, and CAN over SPI and other things. So yeah. So extend the goals. Just take a look at firmware and applications that you can write with this. And yeah, just get some modules out there so that people can play with having an actual ARM powered APU on board doing real-time compute with its NPU or FPGAs. So the final design decisions came down to two things, the two form factors. We wanted to keep one comparatively cheap and light, so we targeted the 96 board CE form factor for that. That gives you a size of 102 mm by 62 mm, so it's kind of like F450 drone, if you know that standard from DJI, or it's a mid-size quadcopter, and it's built to cost to be decided. These are still in production. As you can see, there's a large gap in the slide, and I was supposed to have photos of these boards, but due to the current situation of the market, every vendor is kind of backlogged with previous year's orders, and yeah, we are kind of delayed by a month. So again, this comes out in April. To me, GA is whenever we get down to fixing bugs with the first rev of the boards. So that's something to look forward to on the 96 Boards blog. I'll be updating on everything there. But yeah, coming back to the track, 96 boards CE mezzanine, again, compatible with the CE spec. So just like any of our CE mezzanine, you can just add it to top of your 96 board stack. And we'll talk about interfaces in a bit. And the next one was the 96 board SOM baseboard. We are targeting the RK3399 SOM. The 96 board SOM spec muxes a lot of things, so we have not targeted the generic SOM platform. So it will be designed for the RK3399 Pro SOM or any SOM that follows the exact same pinout. But the next few revs, that's what we're trying to dial in and to get like a generic 96 board SOM support. But talking about the spec of the board itself, it'll be about 102 by 70.5 so about a centimeter larger than the CE1, which kind of just makes it large enough not to fit on a medium-sized quadcopter, made for hexacopters in mind. And it's feature rich. We've exposed as many I/O to the FMU as we could, and again compatible with the SOM form factor. So talking about hexacopters, you saw the one flying. I have one here, but like it's just too large to fit in the frame that I have right now. So take a look at the blog. I'll have videos of assembling this thing and even blog posts of what all stuff I use. It's mostly made out of things that are already available in the market. And UAV CAN, ESCs, and motors are kind of hard to find, but that's sort of goal for a later time when things are a bit more available and the market opens up a bit more. But this was just what I can find. Luckily, I was able to find a very good frame to work with. So the 96 boards FMU V5X mezzanine. This is the 3D rendering of the mezzanine board. As you can see at the bottom end, it fits on the 96 board CE pinout. And at the top, you have the pinout for the FMU module and all the IOs you need to connect to your drone. So these are the octals for your drone ESCs and your RC in, and then here's your serial and I2C buses and GPS bus for all the peripherals, and then your GST connectors for battery voltage and everything else, plus two camera headers, and you can attach as I think these are for the generic Raspberry Pi cams. And kind of a breakout here. I don't know if you can see very well, but basically apart from the things that I already said, octal headers, GPS headers, RC input. We have a CAN transceiver, so that also I think breaks out to this one of these headers, and then we have two CAN transceivers. I think we have onboard CAN jumpers as well, and then the connection between the CE board and the autopilot is basically over I2C and UART. So that's where we are limited on the CE spec. If I quickly move on to the next one, this is the SOM spec board where a lot more things are exposed. So you can see at the bottom we have the SOM pinout, and at the top the SMU pinout, and we do have HDMI, so a bit weird of drone flying with an HDMI, but I wanted something to have like quick debug with. If you can just plug in your display to your drone when it landed and quickly debug stuff, that would be fun. And then just going quickly over the main connections between the FMU and the SOM, we have the onboard Ethernet to Ethernet connection. So we have a PHY and then a transceiver. So you don't need to plug in Ethernet connector. It just goes over USB. Dedicated I2C, dedicated UART, one UART over USB for FMU debug, and then CAN transceiver over SPI, and a bunch of other pinouts. Again, application ideas. This is something that quickly came into mind: high precision aerial 3D mapping and photogrammetry with like 3D TOF sensors. I'm very interested because we will have one from AD as a mezzanine, and I really want to try that out. That's one of the things. Advanced image detection and tracking, enhanced autonomous flight and collision avoidance. This is where what controls what part of the drone comes in and where a bit of tuning is needed for the FMU to only control the stability, and the AP to control the collision avoidance and the tracking. Precision agriculture applications, terrain mapping, and even like dropping seeds from the air. That's one of the things I've seen happen with drones. First responders and research and rescue. So if you can just quickly generate 3D map or detailed 3D map live of an area that's been maybe in an earthquake situation, where you can just get a very quick 3D map of where the places are, where the rescuers can go, and stuff like that. Even heat mapping, if you can like, get people where people are trapped and stuff like that. And environmental monitoring. So generic, just fly the drone up into there, see what pollutants are there, and just kind of map an entire area. Here are the resources that you can take a look at. 96 boards generic is 96boards.org, and the auto edition specific, there's not a whole lot on that website right now, but again, that's a website to keep an eye out for a lot of the automotive stuff that's going to come out of 96 boards. PX4's website, px4.io, all their information will be there, and the PX4 V5X standard dock and other newer and upcoming V6 standards as well are available. And of course, Gum6, they've been very helpful in trying to get this board manufactured as soon as possible. Yeah, so that's kind of it. I think my pace was kind of all over the place, but yeah, another quick announcement before I close this out. Our V2 CE spec is out, and if you want to take a look, you can go onto that website and click View V2 CE spec. Quickly, like this, just an evolution, mostly from community feedback and what they wanted to see. So take a look before I take everyone else's time. Yeah, thank you, and I guess I can open the stage to questions. I'm not seeing a whole. Wait, I don't even have chat open.
Hey, Sanaj. Great presentation. Right. Yes, in the chat, there's quite a lot of activity. So that's, yeah. Come and join the party.
Why can't I see it?
If you go to chat and then public in the backstage.
Okay, gotcha. So the Mezzanine is basically an adapter to the PX4 model. Yes. Do you consider using LiDAR tech, and is it appropriate for drone? Yes, of course it is. Affordable ones, of course, won't have that much range. But as I said, the 3D TOF is something that interests me more. And yeah, drones do use LiDAR. Actually, in PX4, you just have an option to move your telemetry tracking from GPS to camera or LiDAR, and you can do that if you have an expensive enough one. Yeah, Ultra 96 is one of the things. That's why I was saying FPGA over and over again, because at the back of my mind, Ultra 96 was there. What are the chances? Hi, what devices are on Mezzanine card? Is schematics available somewhere with Ultra 96 R5, or you should be able to run PX4 stack directly on it? So you could, in theory, port the PX4 stack on the Ultra 96's R5 core. But I think you'll need to do a bunch of level shifting for it. And I think it's better to save the FPGA space. I know the R5 is a hard IP, but like even to route stuff to the R5, use it as a real-time copro internally, and just have PX4 handle the FMU module handle the rest. What are the devices on the Mezzanine card? So we will have the schematics available as soon as the boards are available. I don't know if this is very clear, but you can see the exact part numbers on some of them. But once the board's manufactured and released, we'll have full documentation, including schematics. Do you consider also hybrid solution with Cortex R series together with Cortex A or Cortex M? I mean, provided there's a Cortex, yeah. So the Ultra 96 has an R5 on it. So sure, if you attach the Mezzanine spec one to the Ultra 96, you can do that. You can have, I think there's, yeah, I think it has 2 cores of R5 if I'm not wrong. What else? I know PX4 is based on Nutix Autos. Can you please comment on the collaboration model between the two projects? Uh, well, basically, just wanted to uh, try out and expose the Linux environment, a real-time processing environment. Well, that sounds wrong, but to have a Linux compute module fly on the drone in an affordable price and to have that exposed as a developer system. So you fly that, you attach your sensors to it, whether you want to inference on the fly or you want to map things on the fly, or you want to stitch a 3D view as you're flying, as you're going, have it render live to an SSD, to expose all of those, to try all of those situations is why we sort of started this collaboration. Anything else I'm missing? No, I think that's it.
Yeah, I think you got them all there. Great talk, Sahaj.
Yeah, thank you.
Thanks, Sahaj. Thanks, everyone. We'll close it there.